Alright, today we're going to be talking about using the washer method to compute volume. And so the first thing we want to talk about is when to use the washer method. We use the washer method when the rectangle that we are rotating is not connected to the axis of rotation. With the disk method, the rectangle was attached. Washer method, it is not. Second of all, it is when the rectangle is perpendicular to the axis that you're rotating it around. Alright, and so this is going to create a little bit of space here, as you can see in this picture with the washer. And the most important thing to understand here is you've got to come up with two expressions. Capital R, and I want you to write this down on your notes. Capital R is the distance from the axis that you're rotating to the furthest part of the rectangle. Alright, that is capital R. Little r is the distance from the axis you're rotating to the closest part of the rectangle. Alright, that is little r. And the volume of this is going to be determined by this formula right here. It's going to be pi, the integral from a to b, of capital R squared minus little r squared. Now, be careful not to confuse that with this. Capital R minus r quantity squared. That is not what we're doing. It is capital R squared minus little r squared dx. And of course, if you're rotating around a vertical line, you're going to have, so this here would be for a vertical strip being rotated around a horizontal line. For this one here, you're going to have some sort of horizontal strip that is being rotated around a vertical line, and that is when you have the functions in terms of y. So a real simple example would be, let's say we have just some rectangle, and the thickness of that rectangle is 2, and the height is 5, and the let's say we have this distance of 3 right there. Then to find the volume of this guy, assuming that we are, let's say we are wrapping this around the x-axis, then capital R would be 8. Little r, and I want you to write this down for every problem, little r is 3. And so using the washer method formula I just gave you, it would be pi, and then capital R squared, which is 64, minus little r squared, which is 9, and then don't forget about the height or the thickness of this, which would be 2. So we need to multiply this times 2, so that comes out there, and then your final answer would be 110 pi. And that would be the volume of just that one slice. And we're going to do some examples on the next slide. Alright, example 2. Want us to read this here. It says, set up an integral, but do not solve to find the volume. So you should like those. Generated by revolving the region bounded by the graphs of the equations about the indicated lines. This is a great activity for you to be able to determine whether you should use the washer method or the disk method. Alright, so let's see what we have here. In the first example, we have y equals 2x squared, y equals 0, which is the x-axis, and x equals 2. So let's see what we have. We're going to sketch this, and we see that y equals x squared is just a parabola, and x equals 2 is just that line, and then y equals 0 is just the x-axis. And so we want to rotate this in part A around the y-axis. Y-axis is a vertical axis, so that means we need a horizontal strip, because the washer method says that the strip that we are rotating needs to be perpendicular to the axis. So we need an expression for capital R, which is the distance from the axis that we're rotating, which is the y-axis, to the furthest part of the rectangle. And so if we call this point, as we've been calling, x, y, all right, and this is the line x equals 2, then capital R is simply 2, all right, because that is the distance from the axis to the furthest part. Now, little r is the distance from the axis to the closest part of the rectangle, which is just x, okay? So that is just x. So now, because this is a dy strip, everything needs to be in terms of y. So we are, well, let's just see what this point is here. That's important to get that point. When x is 2, our y is 8. So this is the point 2, 8. And so we know that our integral is going to be going from 0 to 8. And we need a pi. Capital R squared, so I'll just write it out, 2 squared minus little r squared. So we got to solve this for x. So y equals 2x squared, divide by 2, and then we get y over 2 equals x squared. Now, we could solve it for x and take the square root of both sides, but keep in mind, what are we getting ready to do with little r? We're getting ready to square it, so it would end up as x squared anyway. So we can just say y over 2 dy, and to make it look a little bit nicer, we'll say pi, integral from 0 to 8, 4 minus y over 2 dy, and that's all we need to do for this problem because it says set it up, but do not evaluate. All right, part B. Now we got the same graph, y equals 2x squared, x equals 2, y equals 0, but now we are rotating this around the x-axis, and so if we draw a vertical strip, we can see that the rectangle is connected to the axis that we're rotating it around. So this is a disk method problem. So let's write that up here, disk method, and the first one was washer method. So disk method is simply pi integral, in this case, from 0 to 2, and capital R is the distance from the axis you're rotating to the end of the rectangle. So once again, if we call this xy, then capital R is simply y, but since this is a dx strip, that means everything needs to be in terms of x, the limits, the equations, everything. So y is defined as 2x squared. So don't forget, the formula is pi r squared. Okay, so you got to square. Don't forget to square. It's easy to forget that. So it's going to be pi 2 to 0. And capital R is going to be y. And y is 2x squared squared dx. And you can leave it like that, or you can make it 4x to the fourth, either one, but that is the answer to these first two problems. All right, parts C and D of the same problem. Let's see if we can set this up again. This time in part C, we are rotating around the line y equals 8. So once again, we have the same region that we are rotating. And so we want to take this region and we want to rotate it this time around the line y equals 8, which is right there. So if we draw our rectangle and then we put a point on that graph and call that point xy. So this point is going to be x comma y. Alright, so now this one's a little more complicated because we've got to find, first and foremost, capital R. Capital R is the distance, once again, from the axis that we are rotating it around to the furthest part of the rectangle. Well, that's just 8. So capital R is equal to 8. Alright, now little r is the distance from the axis that we are rotating. So maybe we will put that in pink. Axis that we're rotating to the closest part of the rectangle. Well, that is simply going to be 8 minus y. So 8 minus y. All right. Now, this is a dx strip, so everything needs to be in terms of x, and y is defined as 2x squared, so maybe I should write this as 8 minus 2x squared. All right, and now we need to plug it into our washer formula, so it'll be pi, and since this is a dx strip, then we are going to be integrating from 0 to 2. So 0 to 2, capital R squared, which is going to be 8 squared, minus little r squared. You got to be careful because there's a lot of squareds here. 8 minus 2x squared. Oops. 8 minus 2x squared, and then the thickness is going to be dx. And you can leave it like that, or you can distribute it through, but once again, we're just setting up the integral, so we'll leave it that way. All right, and then part D, we're going to wrap this thing around, this time, the line x equals 2. So let's see what we have here. Once again, we have the same curve, and now we are taking this and we are rotating it around the line x equals 2. So we are going to use this time a horizontal strip. So x comma y. And this is which method? Well, is the rectangle attached to the axis that you're rotating around? Yes, it is. So this is the disk method. All right, and so all we need to do is figure out what capital R is and plug that into our disk method formula, and we are done. So capital R is simply going to be it's going to be this distance right there. It's going to be the radius. So we need basically to do 2 minus x. 2 is the entire distance, and x is this distance, so that's going to give us this distance right there. So r is 2 minus x, but this is a dy strip, so everything needs to be in terms of y, so we are going to solve this equation for x. So y equals 2x squared. Divide by 2, y over 2 is equal to x, x squared. So we're going to take let's just go ahead and do that. And then we'll take the square root. So x equals the square root of y over 2. So we can rewrite our capital R to be 2 minus the square root of y over 2. And we're going to plug that into our washer formula, so it's going to be pi. And this is dy, so we're integrating from 0 to 8 of capital R squared. So this is going to be 2 minus the square root of y over 2, bracket, squared, running out of room, dy. All right, and that is the answer. Don't forget, this first one is a washer method, and the second one is a disk method. All right, last problem. I don't think we need to do a ton of these in order for you guys to get the idea and the process. Example 3, we're going to put it all together. These problems are called Medley Problems. Called Medley Problems because they always love to ask these questions. They're going to combine the 3 major concepts that we've studied thus far. Area is always going to be part A. Part B is going to be either volume by cross-sectional or volume by rotation. And then C is going to be, once again, either volume by cross-section or volume by rotational. And they always ask these three parts. So part A, this is a calculator problem. This is from 2010 BC #1 free response problem. You have the curve y equals 4, natural log of 3 minus x, the horizontal line y equals 6, vertical line x equals 2, and it says find the area of R. Alright, so number 1, area. That should be pretty simple for us because all we need to do is the upper minus lower curve. Alright, so let's say we draw a rectangle right there. It's upper minus lower. So we're going to integrate this thing from 0 to 2. Upper curve is the line y equals 6. Lower curve is 4 natural log of 3 minus x dx. And when we use our calculator, that's going to give us 6.817. All right, this is a calculator problem. And part A is done. All right, now part B, find the volume of the solid generated when it is revolved around the horizontal line y equals 8. Okay, well, y equals 8 is actually up here somewhere, right there. So we can see that the rectangle that we are rotating is not connected to the line y equals 8. So since that is the case, we know that we need to use the washer method. Washer method. Alright, so maybe for this one, since the picture is a little bit small, maybe I will draw this one here so that you can really kind of see what's happening here. Here is our region R. Okay, we'll call that region R. And the line that we are rotating it around is up here. Y equals 8. Alright, so I'm going to draw a representative rectangle. There it is. And I'm going to call this point right there XY. Hopefully you're getting the feel for these problems. Alright, so this one can be a little tricky. So capital R, once again, let's review. It is the distance from the axis that you're rotating to the furthest part of the rectangle. So that is simply going to be 8, which is the whole distance. Okay, that is 8 minus y, and that's that distance, will give us capital R. So 8 minus y. But y is defined as 4 natural log of 3 minus x. Alright, and then little r is the distance from the axis that you're rotating to the closest part of the rectangle. Alright, so that is simply going to be 2, because this is the line y equals 6, and this is the line y equals 8, so there's only a space of 2 there. So all we're going to do now is just plug this bad boy into the formula, and we are done. So we got pi, and 0 to 2, because this is a dx strip, so we're integrating from 0 to 2 on the x-axis. Capital R squared, which is going to be 8 minus 4 natural log of 3 minus x. I'm going to put a bracket and then a parenthesis. That way we're not confused at all. That is our capital R, put that in quotes, squared, minus little r, which is going to be 2 squared. So that'll be little r. Alright, and all of that is multiplied by dx. And so that is going to end up giving us 168.18. And that is the volume rotated around the line y equals 8. And then the last one, part C, so we'll call that part C. I'm calling it 3. Why? I don't know, because I started with 1, 2, 3, and so I'm going to end with 3. Should be A, B, and C. I think you got the point. Region R is the base of the solid, and so now we want to build on top of this perpendicular to the x-axis and squares. So I'm going to use the same picture here that we have, and we can see that if it's a square, it's just going to basically come out of the page like this, come out of the page like this, and there's your square. Alright, so the length of the square is simply going to be upper curve minus lower curve. So it's going to be 6 minus 4 natural log of 3 minus x. And don't forget, it's a square, so the height of the square is going to be the same. So we can just square this guy. And we're integrating once again from 0 to 2. You don't need pi because we're not rotating anything. And then that's going to be dx. Write that in there. And then we can let our calculator do its magic, and we are going to end up getting 26.27. And that is the answer to this Medley problem, and we'll practice these tomorrow in class.